I'll record
Or,
it. I'm doing it. My bad. Just remind me,
okay,
next class. Okay. So dot is a special directory that means here. Dot dot means back one. So if I say pwd and it gives me home gzon, what does dot dot refer to? Home. Yeah. So we're going up one level. And so if I say cd dot dot, that should take me from home gzon back up into home. Okay, and sure enough, there it is. I'm in home now, and I can look around and see everything. And sure enough, there they are. There's not much going on in my home directory in this computer. I've got three current directories. One is this directory. One is the previous one, which is my root, and one is gzon. So I can say cd dot dot again, and that should take me to what? Root. So pwd shows me just the root. This is as far back as you can go. There's nothing above this in any file system. And if I look around here, I see a bunch of stuff that is better not messed with at this point in your computational expertise level. These are things that can really kill your computer if you mess with them incorrectly. So most of the time it's off limits and they require you to enter a password if you make any changes whatsoever for good reason. But I'm going to do cd again, and this takes me home. You notice that my cursor prompt has this little squiggle, the tilde. That's the shortcut for home. So I can also say cd tilde from anywhere in my computer, and that will take me home also. All right. I would like you to make a directory called shell practice. mkdir is make directory. Shell practice has an underscore, not a space. As you'll see, you are never allowed to use spaces in file names in here, ever. This is part of your new religion. I want you to like chant it every night before bed. No spaces in file names. And that's like for the rest of your life. You're part of the cult now. I'm sorry. You do command line computing. You no longer use spaces.
When you're like typing something and you like use the apostrophe, which apostrophe are you using? Like there's like a one with like under the tilde on the keyboard, and there's like
Yeah, so I can do space in file name with that little backtick.
Mhm.
But we don't like that. That's gross.
Okay.
Yeah. That's disgusting.
Yeah.
It makes coding really hard. It makes working with things. You got to remember all this stuff. So underscores are happy. We call this snake case file naming. Some people do camel case where you're capitalizing the first letter of each word, but that is suboptimal because it's really hard to split up that word afterwards. If we have underscores, we can easily split things up. So make dir, mkdir shell practice. Great. How do I check to see if it's actually there? ls. There, I see it. Beautiful. So we made that directory. How do I go into that directory? cd. And here's a little trick. I'm just going to type sh, and then I'm going to hit tab. And it auto-completes for me. I want you using tab complete because it means you don't have to spell things correctly. And we make spelling mistakes all the time. We accidentally capitalize things. So if I were thinking like scale practice and I hit tab, it's going to make an annoying beep at me. the tab is telling me there's nothing here that starts with that. I can't autocomplete it for you. And so I'm like, oh, wait. So SHE should be enough. Shell practice. Use that tab. Okay, PWD shows me where I am. Gthon shell practice. So it's just folders within folders. This concept is not, it's not rocket science, right? But it's something that we have to always keep in mind. Everything we do starts and ends in some location. And we may be here with our script, but our files that we're trying to work on are somewhere else. We need to be able to show our script how to access those files and bring back the results. So let's make a couple new directories. We've got data and scripts. And that should show you something about the behavior of the mkdir program, is that it'll make as many directories all on one line as you want. So I'm going to say, make those two. And then I can look around. There they are. Questions so far? You're like, you said this was a steep learning curve. This is easy. It's true. Working on foundation. I promise you're going to hate it soon. All right, let's create a new file, an empty file, using the touch command. Touch will create an empty file if that name doesn't exist, or it will update the last accessed timestamp on that file. And so we just need to tell it, I want to make a file called raw.fastq and hello.sh, but I need them to be in data and scripts respectively. So I'm going to say touch, hit that tab complete. All right, pick this apart. What are we doing this single command?
Two files.
Making two files. Where are they going?
One's going into data and one's going into scripts.
One's going into data, one's going into scripts. They both start with a dot. Why? I did say that everything that starts with the dot is hidden. I should have said everything that starts with the dot except just dot and just dot dot. Yeah, so.
Does it mean here?
Means start here. Okay, so this is a relative file path, meaning it starts from where I am. Start from here, look for something called data, put a file called raw.fastq there. If that file exists, just update the timestamp. If it doesn't, touch it, create it. And so there we go. Okay. ls dash capital R. This is recursively list. So it's going to list everything that it sees here in shell practice, which is just data and scripts. But then it notices that data is a directory, not a file. And so it's going to look inside of that and say, hey, here's what I see inside of that. In scripts. So there they are. Not all of you are going to have this command. We can install it for you later, but there's a convenient one built into Linux called tree that shows you a directory structure, how things exist within each other. You try tree and it says, I don't know what you're talking about. Don't worry about it. Once you're on the HPC, they've got tree built in. So the relative file path from here into data, raw.fastq. Okay. Type CD, hit enter. I would like you to copy that raw.fastq directly into your home. We are in home now. But you can't leave home. I don't want you doing CD. And here's the command for copy, CP. And here's how it works. From to. So copy some file location to somewhere. And I'll go ahead and tell you that to get it to come here, you say from wherever to here. Bring in raw.fastq to here. Got it.
No
Okay.
error.
An error?
Beautiful.
Beautiful. No, yeah, what's the error? I love errors.
CP from, and then it's or is it CP, colon, from, space from, colon, no such file.
Did you type literally CP from? I'm so sorry. What I meant is the path to whatever file. So copy that program. It wants some file or list of files and directions for how to get to them, and then where they should go. That make more sense?
Yeah,
My bad. Happy? And Rosie?
We're supposed to be putting the raw.
Into your home. Morgan? Still not working?
They're still trying to.
Okay. Sarah?
Still figuring it out.
Okay. Sarah? You need this comment? Still confused, okay. Tanya?
I am also still confused.
Okay, now, what if I show you where I am, home JSON. If I look around, I see shell practice that we just made. I know that the file I want is in shell practice. And then in shell practice, it's in a folder called data. And it's named raw.fastq. So watch this. If I copy, and I'm going to use tab to make sure that I'm going in existing place. Starting here, SHE tab. And then I'm like, oh, what was the name of that folder? I'm going to hit tab a couple times. And it's going to show me what's available. Oh, yeah, it was called data tab. And then raw.fastq, I didn't have to type that, it was the only file, so I hit tab. If I copy that file to here, would that make a bit more sense? So currently I'm in my home, and so if I want any access to raw.fastq, that file that we made, it's not here, and if I say copy raw.fastq to here, it's like, excuse me? I see nothing like that, and it's going to give you an error, and it's going to say does not exist. It's your computer will not lie to you. It's really literal and a bit stupid. It needs total instructions, but one nice thing about it is that it will not lie. And so when it says file not found, it means something's wrong, you're not giving it the correct path, or that file just doesn't exist and you forgot to put it there. So I've got a program which is CP, and it wants at least two parameters. The first parameter is where the file to copy from is and what it's saying. And then the second parameter is where do you want me to copy it to? So relatively speaking, relative to my home directory, that's the file name. That file name actually includes that whole path to the file. And so we call this a file path. And this is the essence of how file systems work in a computer. And this is not how they work in an iPad. Okay. Questions about this? I want this to really make sense. I want you to like look at that and go, oh, duh. If you're not there yet, I want to get you there. So let me know. Yes.
So just kind of interpreting through it, so like the from to, so like we're taking the raw FASTQ from the data from the chef practice and taking it to
Here,
the root or here.
here.
So the dot, like the slash is just like.
Dot
taking it to
slash
here.
means here. Yeah.
Okay,
Just a slash means root.
yeah. Oh, okay, okay.
Yeah, my bad. I could just say dot, but I always like putting the slash because directories have a slash after them. It makes me happy. And it also enables me to start hitting tab and seeing what's available. Like, oh yeah, I've got Snap and Shell Practice and downloads. Right. So I maneuver through my computer almost always in the terminal at this point for just even doing basic file tasks because tab and autocomplete is faster than me like searching and clicking and dragging stuff. So copy that file to here. We had to tell it where that file was though. And this is a killer. Like still to this day, most of the errors that I get working on an HPC are because I think files are in one place, but I'm telling my script that they're somewhere else. By far the most common problem. So I'm copying that file to here. Done. And then I'm going to look around with ls. And I should see raw.fastq. Ah, there it is. Sanity is restored. Okay. But you've got somewhere on your computer a biocomputing directory, right? That you created and stuck up on GitHub. Or is it just on GitHub and not on your computer yet? I don't know. It depends on you. Did you clone yours already? Okay. Anyone else? You've got a biocomputing repository somewhere. But that's just in the cloud. And what is the cloud? Somebody else's computer. There's nothing magical about it. It's just some server in Belarus in the basement or something. Like the cloud is just somebody else's computer, but you don't have it on yours. That's okay. We can clone that repository, meaning we're going to take it from online and bring it to your computer. So the way to do this, I'm going to do it from my home, is go ahead and navigate to your online repository. For biocomputing. You don't have any of this stuff in there, that's fine. But you've got a README file. Okay. So in your online repository, there's this big green button called code. You can click that and it gives you this little like, oh, copy the URL to clipboard, or you can go up to the top and copy it. But this is nice and easy. Copy that to your clipboard. And then in your terminal, wherever you want to put this. So where do you want to put it? This is where it's going to live for the duration of the semester, probably. You can move it later if you want, but where's a convenient spot on your computer? Where do things go when you download them?
It goes to like a downloads folder, like the directory, like downloads.
It goes to a downloads directory. Where does that directory live? Does it?
It's not actually one more.
See, this is weird, right? Like, we just download stuff and it goes to downloads and we're used to just like, oh yeah, that's where it is, and we click and we grab it. Or we just open the Finder and start typing the name of the file and it kind of comes up. Or we open Word and go to the like recent files tab and like, oh yeah, there's my paper. All of those things that you just clicked on actually live somewhere on your computer, like with a specific address in the file system, how to get there. You will either start thinking in terms of file locations, or you will fail at this class and all future command line stuff. Okay. So if I say, where does your downloads go? And you don't know, it's not your fault. It's because Apple's made it really convenient to just start typing the name of the thing, or, hey Siri, where's that file, right? Well, it lives somewhere. And so I want your biocomputing directory to live somewhere where you know it is and where it's convenient. So that might be your desktop. That might be your home. For me, I put everything in desktop Git repositories because I've got a crap ton of them. And it's just easier for me to kind of keep track of them that way. But that's not necessarily best practice for you. So you might just want to put it in your home so that if you're looking for your biocomputing, you just have to hit CD and you're like gonna be seeing it. So I don't think that's a bad spot. If you want to stick it somewhere else, if you do CD in your home and you see desktop, well, then you could put it in your desktop really easily as well. And the path to your desktop is home, desktop for me. On Macs, that's usually the case also. But I want you to put it somewhere. I'm gonna do this in my home directory because I've already got this in biocomputing or in my Git repository. So just to show you, here's the magic sequence. Git clone. You've seen git add, git commit, and git push. Git clone takes anybody's repository that you can find online. And then we're going to paste in that URL that we copied earlier. So I right click and paste. Control C, Control V don't work in your terminal. It's like Shift Insert or something or other. For me, it's Control Shift C and Control Shift V is the copy paste. But you can always right click. So this is me about to clone that whole repository that's online into my home directory. So I want you to do that with yours.
Are you like posted using different desktop like that?
For this class, yes. Yeah. Because how are you going to do that on a HPC?
Yeah.
So I want you using the command line because it's transferable. But in general, in life, no, by all means, the GitHub desktop is lovely. I find that I don't use it because I'm always working in remote systems. All right, anyone have an error or anything when you did your clone?
It's warning.
Okay, so you didn't have a README file present? Okay, that's all right. All that means, if it says you appear to have cloned an empty repository, what that means is that when you were setting it up, you forgot to check the add a README, but we can add one for you now, it's fine. What I want to see is that when you hit LS, you see biocomputing. Okay, perfect. Yours will just be empty. Most people should have a README in there. Go ahead and go into it. How do I do that? CD? That didn't work. CD biocomputing. That didn't work. CD space bio, and I hit tab, I don't want to type out computing. So I'm in there. If I do ls, I see some stuff. Vera, you probably see nothing when you do ls in there?
Yes.
Okay, good, that's nice and sane. If you want to fix that, go ahead and do touch readme dot md. Create yourself a nice empty file. There, I'm just updating my timestamp since that already exists.
So what does it do if you already have file?
Updates the timestamp, so you'll see that every file actually has like a when it was last modified. These are all 1029. This one's more recent because I just touched it.
Does that like bite the file or is it?
No,
It's just the.
it just like a light little touch updates the timestamp. This comes in handy in a high performance computing environment because it's a shared space. And so there's usually a time limit on how long you can have files stored, especially in like the shared memory. And so you may have like some big sequencing project or who knows what sitting there, and in 2 months it's going to get deleted. How do they know it's been 2 months? The timestamp. So all you got to do to keep it from being deleted is touch it. And that they know that people do that. It's just a way of letting them know that, hey, I'm still aware of these files, I'm using them. So now you've touched a file, it's gonna be an empty file, but that's fine.
I can't get into biocomputing, it is in my list, but it doesn't pop up or you see.
I see biocomputing. Okay,
Never mind.
you spelled it wrong.
I must, yeah.
Yeah,
There we go.
there you have it. It's okay. It's user error. I've heard of it before. No, yeah, this is why tab complete's so handy. I spell stuff wrong constantly. So I'm just always in the habit of like tabbing, and it makes it annoying. I hate that sound. Triggers me at this point. All right, so we're in there. I want you to go ahead and make an assignments directory. And within assignments, I want you to make assignment 01. So it'll look like this. Our making directory command. mkdir. So if I go into my assignments, I've already got assignment 1, but I'll show you what this might look like. Make dir assignments. It's going to give me a warning because it already exists. And then I could go into assignments and make dir assignment 01. Great. Then I'm going to go into assignment 01. I'm going to do a PWD just for a sanity check. This is always nice, just every now and then check in on like, where am I? Okay. I'm in my home in biocomputing. Inside of that is assignments and assignment 01. Perfect. Okay, if you look in our lesson 1 document, you'll see that I want you to have 3 separate directories and then a readme.md. So I'm gonna make data, scripts, and output. And then I'm gonna touch readme.md. Great question. Why do we do that? Well, first off, this is where you're gonna be turning in assignment 1. Okay, which you can start working on later this afternoon or right before it's due, whenever. So we are making a directory structure for a project. And this is actually really important that we try to keep every project self-contained in its own directory. This makes it portable. Right? But more importantly, that portability means that all of our file paths will start from there. So I'm in assignment 01. If I do my little fancy tree command, you can see that I've got data, output, and scripts, and then a README. What do you think goes in the README? Stuff that I want people to read. So in assignment 1, there'll be like a little essay for you to write. But for the most part, this is documentation for somebody coming to your project. They should be able to tell them every single thing they need to know about what's going on. This makes it reproducible. And the person who needs to know about it most of all is future you. Because 30 days from now, you will not remember, I promise you will not remember what was happening, or where your files are, or what's going on, or why you name things a certain way, all of that. So the README is like a good documentation place. And then we've got a separate spot for data, a separate spot for output, and a separate spot for our scripts, the actual code that we write. This is good hygiene. We want to keep our scripts separate from our data. The data lives in its own folder and never gets touched. It's read only. In fact, we can even set permissions, and we will. So it's read only, and you can't accidentally delete it. You can't change anything because the data is sacred. It needs to stay raw. Everything we do to it for any sort of insight and analysis comes through scripts. And so somebody else starting from your raw data using your scripts should get the exact same output in that folder. And they should understand how that's working because they read the README. So this is like the basic minimum of what any project might be. And in this class, we're treating every assignment as its own separate project. So each one is going to live in its assignment 1 directory. And so here I am in assignment 1. There's my path. But if I'm going to tell somebody like, oh yeah, I've got this like README, or let's say I'm going to touch out1, output, out1.txt, whatever, sure, I'm just making some dumb files. So there's a file that lives in my output. What are the directions to get to that file? Well, there it is. There's the directions to get to my out1.txt file. So if I put that into a script, like, hey, put this file here, and then I give you this project and have you run it on your computer, what's going to happen?
It's not gonna work.
It will not work. If it does, that means that you have a folder called G's on in your home, and that's creepy. I don't want to know if that's the case, right? So the thing is that this is an absolute file path. It starts at root and goes here. And your computer works that way in the background, but it's not portable. It only works on my computer. Really only does. It won't work on the HPC. The absolute pass on the HPC will only work on that HPC, not even a different cluster here at William and Mary, and it definitely won't work on your computer. So keeping every project as a self-contained folder means that I can absolutely start all of my file paths with here. They all start from assignment 1. And so what I can do is say my path to that is output out.txt. Oh yeah, need to give it an end. So there we have it. That's a relative file path. If you look through lesson 1 on your own time, you'll see a nice little table of differences between absolute and relative. We will not work with absolute file paths in this class. Ever. Because everything we do needs to be reproducible. And truly reproducible science is reproducible on more than one computer. Yes.
What is LL in arbitrary?
Oh, my bad. I've got a shortcut, and that means LS list, long style. Yeah.
Okay, thank you.
We'll see those next class period, and we'll learn some more of these like little tips and tricks. Okay, the last thing I want you doing today is going back one, CD ... and wait. I need to go back to biocomputing, the main. So check this out. Go back one and then back one again. So I'm in assignment 01 currently. I want to go to biocomputing, the main directory for our whole class. So I need to go back to assignments and then back to biocomputing. So we can chain those together with the slash. Okay, and in biocomputing, I look around ls-l. I see file 1 is there, see assignments. What do you want in yours? I'm not going to enforce anything for you except the assignments. A README would be nice. So if I look at my README, it's just got some dumb stuff in it. Okay. ls-l. So a README might be nice, saying like what this is, like, you know, the course number or whatever. You definitely have to have assignments. I mean, assignment 01, assignment 02 through 8. But other than that, if you're an adult, you can put whatever you want in here, but this should be a spot that's useful to you. So stuff like the lesson files, you can download those and have them convenient. If you're taking notes on stuff in class, why not put them in here? Right? We've got the online Google Drive. If you prefer to do it that way, that's fine. But I want you to start thinking, and you don't have to do this right now, but like, what do you want to be in here for your biocomputing that's going to be pushed online? Right? So maybe a spot for notes would be good. Maybe a spot for the lessons. You can have a little text file open at all times, taking notes in class, and then just save it as a .txt in your notes. Might be handy. We also have an online Google Doc of notes that we'll kind of be filling out as we go through class. So we have a shared one as well. But you may not like the shared one, you want your own style. I want you to think about how you want to organize this project. And the point of this exercise is that for every project ever, 5 minutes left, for every project ever, you're going to have to think before you start. What do I want this to be? What components do I have? What kinds of data will I have? Is it DNA sequencing data? Right? Is it also RNA-seq data? Should those really live in the same folder? No, God no, but people put them there, okay? Because they don't stop and think ahead of time. Okay, so I want you to be in this mode of, and it'll get easier as you start working with this, and the way you do things now will change by the end of the semester, but thinking about it won't change. So what you think about will change, but the process, I want you thinking, what's going to happen in this semester? What are the things that I'm going to need to keep track of, and how do I keep them organized and separate? If I look at tree here, you can see how I've got it organized. Here's my assignments. Got some test files in there. So assignment 8, I've got data, but so far I've really only got metadata, okay? Because the raw data will be gotten by this script. So I've got an R script that will actually download the raw data and populate the data folder. Then I've got my group project, And then I've got my lessons, and I've got a markdown file that's just plain text for each lesson. Where I'm just taking notes. And I've got resources, so some notes and some practice exercises. You don't have to do it this way. But I want you to think about how you want to do it and then make it. So once you've made it, I'm gonna just create another stupid new file. Go ahead and type in get status. You got any new files to track? Anything? Okay. Then the practice here is there's three things that you've got to do: add, commit, and push. Okay, if you look in our lesson, there's even a nice cartoon for it about what's going on with Git. It's this little buddy here. Okay. And we can do this next class period too. You don't have to have this down and ready right now. Git add the new file that I care about. Git commit, you must give it a message in quotes. My message, whatever you want to call it. That message should be like, normally it should be something reminding you of why you made this commit, like, hey, we fixed a bug, or we're changing the logo, whatever. Commit it, and then git push. I typically do this at the end of the workday, every time I'm working on stuff. Or I do it once I've got something that really, really works and I'm happy with it, I'll add commit push. So give yourself a new file. I don't care how you make that file. If you open up Microsoft Word and save it as something and save it in there, great. But we're down to like a couple minutes for questions, comments, anything.
Assignment 1, 2, remember?
No, your assignment 1 will be due before class next Tuesday. No, sorry, next Thursday, since we only have one class period this week. So a week from now, assignment 1, that it'll be plenty of time. We can work on it in class together next class period too, just especially for that first one, make sure that we got like the workflow. What's it like to actually do an assignment, save it correctly, push it to GitHub, and then I'll go and look at it and make sure it's there for grading. What else? Concerns, fears? You're gonna go cry in your pillow? Overwhelmed with the beauty of life? You're gonna practice making directories? Go through the lesson, but we will finish it up next class period. So if there's something you super don't understand, it's okay. We can just like, we can glaze over it for now, or ChatGPT can help fill you in. It's usually pretty good about bash stuff. Yeah.
So like I tried committing my all of like the assignments folder and the assignments one just now. And I like the README file was like the only one within the assignments folder. Like I committed, but like the data output and scripts directories.
They won't show up in GitHub unless there's a file.
Okay.
They're committed, but GitHub will only display them if there's at least a file in each. So they're okay.
I got an error saying, author identity unknown.
Okay, so go through that like setup document assignment 0 again, and that'll take you. There's just a couple lines you can copy paste in, like that GH auth, that thing. You'll just have to do that and just set up for your computer your username and password kind of thing. Everything good on your end, Tanya?
Yeah, kind of.
Kinda? Okay. kind is better than no, I guess, but we got time, and next class period, we'll just pick up from here and make sure we're all on the same page. All right, get the hell out of here. Bye, Tanya.